Welcome to the Tech Academy, where we provide in-depth analysis of electrical components. Today we will be analyzing the electrical component, the capacitor. A capacitor is an electronic component that gathers electric charges on two conductive plates that are insulated from one another and stores electrical energy in an electric field. It has two terminals and is a passive electrical component. Capacitors are unique because of their capacity to store energy. They resemble fully charged electric batteries. As we often refer to them, capacitors are used in a variety of crucial circuit applications. Local energy storage, the prevention of voltage spikes, and complicated signal filtering are typical uses. Energy storage, power conditioning, electronic noise filtering, distance sensing, and signal coupling and decoupling are some of the most typical uses for capacitors. Capacitors are employed in a variety of industries because they serve an essential and adaptable function in a wide range of applications. A capacitor's schematic representation closely resembles the capacitor's physical form. A dielectric substance and two metal plates serve as the building blocks of a capacitor. The dielectric is positioned in between the parallel rows of very close-spaced metal plates to prevent them from touching. Anything that will obstruct the flow of current, including paper, glass, rubber, ceramic, and plastic, can be used as the dielectric. Aluminum, tantalum, silver, or other metals are some examples of conductive materials used to make the plates. Each of them is attached to a terminal wire, which finally connects to the other components of the circuit. How a capacitor is built determines its capacitance, or how many farads it has. How a capacitor functions. Electric charge flows as electric current, which is what electrical components use to operate, light up, and perform other functions. Charges become stuck on the plates of a capacitor when current flows into it because they are unable to pass through the insulating dielectric. One of the plates becomes overall negatively charged when electrons, which are negatively charged particles, are drawn into it. The opposite plate becomes positively charged when a huge quantity of like charges on one plate pushes away like charges on the other plate. Due to the nature of opposing charges, the positive and negative charges on each of these plates are drawn to one another. Even though the dielectric is there to stand between them, the charges will always be stranded on the plate, until they have somewhere else to go. These plates' stationary charges produce an electric field that affects the potential energy and voltage of the electric current. Similar to how a battery might store chemical energy, a capacitor that gathers charges in this manner is storing electric energy. Because the positive and negative charges on each of the plates of a capacitor are attracted to one another but never touch, the capacitor can maintain its electric field and hold its charge. The capacitor plates will eventually become so clogged with charges that they are unable to take on any more. One plate contains enough negative charges to resist any additional ones that attempt to connect. This is when a capacitor's capacitance, farads, which indicates the maximum amount of charge the cap can hold, comes into play. The capacitor will discharge if a path in the circuit is made that enables the charges to find another path to each other. In conclusion, we are more familiar with the electrical component, the capacitors, and some of its uses. For more informative analysis, like, share and subscribe. Please like, share and subscribe, and thanks for watching.